Hello children, in this lecture we will discuss reactions of aromatic amines. So these aromatic amines are also known as aryl amines. Okay, so the first reactions are electrophilic substitution reactions. These are the substitution reactions which are taking place in the presence of electrophile. So in these reactions, electrophilic substitution reactions, one or more hydrogen atoms of the benzene ring get substituted by electrophile. So that is why these reactions are also known as reactions of benzene ring. Okay dear. So as we all know that in aniline, which is an aromatic amine, NH2 group is orthopara directing. Okay, why it is orthopara directing? This can be proved with the help of resonating structure of aniline. So as you can see here that these lone pair which are present with amino group here with nitrogen. So these will be these lone pair of nitrogen will be given to the benzene ring in this way. Okay, so this amino group which is carrying a lone pair with a nitrogen atom is going to increase the electron density of the benzene ring. Okay, and due to this resonating effect, you can see here that ortho and para positions are taking electrons density comparatively higher than the meta position. So it means this NH2 group is orthopara directing in aniline. Okay, so because this NH2 group is showing highly directive influence, that is why the NH2 group activates the ring to such an extent that it is difficult to check the reaction at the mono substitution stage, and usually 2,4,6 tri-substituted derivatives are obtained. Okay, so this is a very big problem in the case of aromatic amines. NH2 is highly activating group, and that is why it is not easy to obtain mono substituted products in a normal condition. Okay, so what we are going to do to get mono substituted product, we will protect the NH2 group which is present in aniline by acetylation. Okay, so by introducing acetyl group with NH2 group. Okay, due to the acetylation, this NH2 activation of NH2 group will be become comparatively very less. Why? Because these lone pair of electrons will be get conjugated with this acetyl group, and that is why these will available for conjugation with this ring will be the chances will be very less in this condition. Okay, so in this way we will able to deactivate this NH2 group, and this deactivation of this NH2 group in this way is known as protection and is used to control the rate of reaction and to check the formation of di and tri substituted derivatives. Okay students, so whenever required, the acetyl group may be removed. How we can remove acetyl group? By hydrolysis to get back the NH2 group. Okay, so aniline is giving some typical electrophilic substitution reactions, and out of these reactions the first is halogenation. So halogenation of aromatic amines occurs very fast due to the strong activating effect of NH2 group, and Substitution takes place usually at ortho and para position in the ring, even in the absence of any catalyst. Okay, so for example, we can you can see here that when aniline is reacting with bromine water, we get tri-substituted aniline, which is known as 2,4,6-tribromoaniline. So this white PPT of tribromoaniline is obtained. So this reaction we are going to use for the testing of aniline also. Okay, now if we want to get monosubstituted bromo derivative of aniline, so first we have to protect this group. Okay, and for the protection we will do acetylation of this NH2 group with the help of acetic anhydride. Okay, so acetanilide will be obtained. One hydrogen atom of the amino group will be removed by this acetyl group. After this we will do bromination of the related this acetanilide. So in this way we will get ortho and para derivative, monosubstituted ortho and para derivative of aniline. Okay, and these derivative will be get converted in the form of ortho and para derivative of aniline. So for that we have to hydrolyze these two products to remove to convert this NHCOCH3 group in the form of NH2 group. Okay, so after hydrolysis we will again get back this NH2 group. So in this way we will obtain related ortho and para derivative of aniline, monosubstituted derivative. Okay students, the next reaction is nitration. So direct nitration of aromatic amines using concentrated nitric acid and sulfuric acid does not yield satisfactory result because nitric acid is a strong oxidizing agent. Okay, so that is why first we will protect this amino group, and after that we will use nitrating mixture, concentrated HNO3 and concentrated H2SO4. Okay, so in this condition we will get ortho and para derivative, mixture of ortho and para derivatives, and after hydrolysis finally we will get ortho and para nitroaniline. Okay students, next is sulfonation. So in sulfonation protection of amino group is not required, but the drastic conditions are required here for the sulfonation of aniline. So as you can see here, when aniline is treated with concentrated sulfuric acid under condition of 453 to 473 Kelvin for 4 to 5 hours, then finally we get para substituted sulfonic aniline, which is simply known as sulfonilic acid. Okay, and this sulfonilic acid can exist in the form of bipolar ion, and such bipolar ions are known as Zwitter ions. Okay students, so bipolar ions, why these are bipolars? Because this single structure is carrying both positive and negative centers. So such bipolar ions are known as Zwitter ion. Okay students, then coupling reaction. These reactions are very important, coupling reactions. So in these reactions the disonium salt is treated with aniline in the condition of 273 to 278 Kelvin. So diazo compound is formed. So these compounds are coloring agents, that is why known as dye. So when aniline is treated with diazonium salt, diazonobenzene is formed, which is yellow in color. Okay, and this yellow compound get converted in the form of para-aminoazobenzene after rearrangement.